Hi everybody, this is the video to do the corrections for these practice set number 15, which is this worksheet here. We're just going to start with these derivative graphs. We already kind of talked about them in the other video, but for those who didn't watch those, we're given the original function here, and we're trying to find the derivative down here. Remember, the derivative tells us the slope. So if my original function is increasing, my slope will be positive. If my original function is decreasing, my slope will be negative. And if my original function has a max or min, then it will be the derivative will be 0. So look at this first one. It's going up. It's increasing the entire time, and it's increasing at the same rate, right? The slope is constant. So I'm looking for a constant function, which is b down here. The next one is increasing, and then it stops, and then it decreases, right? So I'm looking for one that is positive, and then 0, and then negative, right? So positive, 0, and then negative. That's this guy. Positive, 0, negative. All right, keep going. This one I'm looking for one that is, so this is decreasing, and then not differentiable, right? There's a spike there, not differentiable, which means there's probably a hole or something there. And then increasing. So I'm looking for negative, hole, positive. All right, so here you go. Negative, hole, positive. It's not a hole, it's a jump discontinuity, but that's because the slopes aren't different on from the left and the right, right? Next one is interesting. It's positive slope. And then I jump down here and it's still positive slope, right? So it's the same slope on each one because those slopes are the same line. So this is this F graph here where it's that constant slope, but then there's a hole in the middle because of this discontinuity in our original function. All right, for the next one, this one is increasing, 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 in 0 right there, right? It's flat, it's 0 slope, and then increasing, 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 increasing. So it's increasing all the time. So I'm looking for a positive graph. There's no discontinuities or anything. So that's going to be this one, right? It's positive, 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 0, and then continues to be positive, 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 right? And then the last one is constant slope, not differentiable, and then slope that's close to 0, and then slope that gets really big. So here's constant slope, not differentiable because it was, you know, a sharp edge, and then really close to 0 slope, and then gets really big slope. So that's that one, right? So we had, I guess I should have labeled these as I went, but that one was B, this one was A, this one was D, this one was F, this one was C, and this one was E. All right, so that's that. For the next one, we're given R of X is F of G of X, and S of X is G of F of X, and F and G are shown in this figure below. We want to find R prime of 1. First, we need to find R prime, not F. R prime is the derivative, which is derivative of the outside. Inside stays the same times the derivative of the outside. And we're trying to find R prime of 1. So we're plugging in 1. And then we're just finding these values, right? I need to find G of 1 and G prime of 1. Let's start with G of 1, right? G of 1 is over here. If I evaluate G at 1, I get 4. So this is F prime of 4 times G prime of 1 is, remember, the derivative tells us the slope. So basically I'm asking, what's the slope here? It's a flat line. The slope is 0. So I'm multiplying this whole thing by 0. I'm just going to get 0. Next one's the same thing. S prime of X is going to be G prime of F of X times F prime of X. And this time we're plugging in 4. So it's going to be S prime of 4 equals G prime of F of 4 times F prime of 4. And now we just need to find these things, right? First, let's find f of 4. F of 4 is right? 1, 2, 3, 4. Right there. So it's looks like 3.5. Alright, so it's 3.5. So this is g prime of 3.5 times f prime of 4 is, again, what's the slope here? That's f prime of 4. It says, what's the slope right here? And well, the slope of this line is 3 over 4. So this is 3 over 4. Did I get that right? 4 over 3. 1, 2, 3, 4. 1, 2, 3, 4 over 3. Sorry. And now I need to find g prime of 3.5. So 3.5 is 1, 2, 3.5. G prime of 3.5 says, what's the slope here? Right? G prime of 3.5. And well, the slope of this line is up 1 over 2, 1/2. So I have 1/2 times 4/3, which is going to give me 2/3. So the answer to that one is 2/3. Alright, for this other piece here, we're going to get, or for this next question, we're going to get y prime is, we have to take the derivative of the top. So to take the derivative of the top, we need to use product rule. So that's going to be u prime v minus v prime u, right? That's simply the derivative of the top. And then we have to multiply it by the bottom. We have to multiply the whole thing times the bottom. And then we have to subtract the derivative of the bottom, which is going to be z prime times the top, all divided by the bottom squared. And there you go. Use that one. Okay, let's keep going. For this one over here, the position of a particle given by the function x of t equals, this, remember, was a t, 3t squared plus 2t plus 4. Find the average velocity. So this is just like the average velocity is the average rate of change, because that's what velocity is, right? It's a rate of change. So I'm trying to find the average rate of change, which means I'm going to find x of 5 minus x of 2, right? This is our slope formula, all over 5 minus 2. Okay, if I plug in 5 there, I'm going to get 75. So 5 squared is 25, times 3 is 75, plus 10 plus 4, minus, if I plug in 2, I'm going to get 4, 12, plus 4 plus 4. This is all going to be over 3. 75 plus 10 plus 4 is 85, 89, and then 12 plus 4 plus 4 is 20. 89 minus 20 is 69, over 3 is 21. Right, so my average velocity is 21. Now the next question is asking, at what time, at what t value in the interval from t equals 2 to t equals 5 will the instantaneous velocity be equal to the average velocity? So remember, instantaneous velocity is the derivative, right? That's the slope of the tangent line. So I need to find the derivative. So I'm finding the derivative of my position, which is the velocity, which is 6t plus 2. And I want to know, when is the velocity equal to average velocity? Well, here's my average velocity. So when does my average velocity equal my instantaneous velocity? Right? At what time will this be true? Right? At what t value? So all you're left with is solve this equation. Right? Subtract 2 on both sides, and you get 19 equals 6t. T equals 19 over 6. And that's it. That's your answer, at 19 over 6 seconds. Okay, moving on. Over here, we have take the derivative. We're trying to find an expression for h prime. This is the same problem as before. It's going to be f prime of g of x times g prime of x. And then we want to find h prime of 2, which means we're plugging in 2. Right, we're plugging in 2 everywhere, see an x, and this we're going to find these pieces, right? G prime of 2, right? What is G prime of 2? G prime of 2 is root 2. What is G of 2? G of 2 is 5. So we're going to replace those numbers in here, right? So it's going to be H prime of 2 equals F prime, I haven't done F prime yet, right? Of 5 times G prime of 2 we said was root 2. Right, we said that was root 2. So that's there. And then now we need to find F prime of 5. So H prime of 2 is going to be F prime of 5, which is F prime of 5 pi. So we're going to get pi times root 2. And that is our answer. For this one, notice that we have a product, which means when I'm trying to find K prime, I need to use product rule, which is F prime times G plus G prime times F. Right? And then once I have this, I can find K prime of 2 by plugging in 2. That's F prime of 2 times G of 2 plus G prime of 2 times F of 2. And we're just looking at our chart and plugging these things in and finding what they are. And we're going to get K prime of 2 equals F prime of 2 is E, right? Remember that number E. G of 2 is 5 plus G prime of 2 is root 2 and F of 2 is 5. So our answer is basically just going to be 5e K prime of 2 equals 5e plus 5 square root of 2. Okay, last one here on this is b of x. We have to do the quotient rule. So b prime of x is f prime times g minus g prime times f all over g of x squared. And when I do, and then I plug in all my numbers, I already know f prime and g, right? These are the same numbers from above, so it's going to be 5e minus 5 root 2, right? Remember, product rule and quotient rule were very similar, except for that sign in the middle. So I can just write it like that. And then over g, oh shoot, but we're doing it at 5. I'm sorry, okay. Getting ahead of myself here. We have to plug in 5, not 2. So we're plugging in 5 everywhere. So f prime of 5 is pi, g of 5 is 8, minus g prime of 5 is 7, times f of 5 is 2, all over g of 5 squared, which is 8 squared. And if you simplify this, you're going to get 8 pi minus 14 over 64. You could pull out a 2 out of all these, right? So it'd be 4 pi minus 7 over 32 is your best answer for b of 5. That's your best answer for that one. All right. Last one on this front page. We are trying to find the equation of the tangent line to each one. Remember, tangent lines have this equation. And in both cases, they already gave me x1, y1. Right, they gave me that for both of them. So all I'm left with is find this, which is simply the derivative at x1. So I'd have to take the derivative of these and plug in x1. So before I take the derivative, this one to me is a lot easier without the product rule, because I know I'm going to have to plug in something. So if this can be x to the 4th minus 3x squared plus x, I'm just distributing that x in there, and then I'm going to distribute the 2 in there, and I'm going to get plus 2x cubed minus 6x plus 2, and then just combine like terms here, which will give us x to the 4th, oh, why that went over there, x to the 4th plus 2x cubed minus 3x squared minus 5x plus 2. We still have not done any calculus yet, right? That was just algebra. And now let's do our calculus. Let's take the derivative. We'll get 4x to the third plus 6x squared minus 6x minus 5. We want to know what's the derivative when x is 1. So we're plugging in 1 everywhere. And we will get 4 plus 6 minus 6 minus 5. Those cancel. We're left with negative 1, right? What this tells us is the slope at x equals 1 is negative 1. So for my equation for this line, I would say y minus negative 3, which turns into a plus, equals negative 1, x minus 1. Done. Right? Part B, we need to use quotient rule. There's no way to simplify this, so we're just going to go ahead and use quotient rule. Derivative of the top is 0. Minus derivative of the bottom is 2x all over 4x squared. And simplify, we're going to get y prime equals negative 16x. This whole thing needs to be squared. Negative 16x over 4 plus x squared, quantity squared. We're going to plug in negative 2, right? Because we wanted a slope at negative 2. So what's y prime of negative 2? Well, it's going to be negative 16 times negative 2 over 4 plus negative 2 squared, quantity squared. This will be 32 over 16 squared, which is 96. 16 squared. I just don't want to get it wrong, and then 256, 256. And then simplify this. There's a lot easier way to do this, but both of these are divisible by 16, so you get 2 over 16, which is 1 over 8. So that's my slope for this one. So my equation would be y minus 1 equals 1/8 x minus negative 2, which turns into a plus 2. And you can just leave your line like that. Okay? Alright, that's it for this one. I'll make another one or two for the back of this as well.